Hey, Vlad here, devinsideyou.com. Welcome to another video. In the previous video, we implemented the initial version of sets, which was a very mathematical version, but then we realized that we have no way to have a link between elements, right? So we couldn't walk through them, and therefore we didn't know how to implement isSubset. And today we're going to revamp the entire implementation. Alright, so we're in the Ubuntu virtual machine again, and this is exactly where we left off. This time I have the terminal at the bottom and Sublime at the top. We left over here where we had the isSubsetOf, which was a pending test. Let's start SPT and actually run the test. And in the meantime, I'm going to show you, okay, this is the production code where we have the isSubsetOf that, as of right now, just throws in implemented error. So let's run our test. And we should see everything should be green, and this one should be yellow because it's pending. All right. So I also realized that I forgot to add one teeny tiny test. So before we keep going with this one video, I'm just going to add this teeny tiny test. So this test is for the remove function. So if I go up somewhere, we have remove over here, remove over here, remove over here. Okay, this is the very first one. I actually forgot to add the very first test for remove that if we remove an element from an empty set, I don't want to throw it any exceptions. I just wanted to, to return an empty set, right? So we're just going to say remove on an empty set should yield an empty set. I'm trying to avoid having any changes outside of the of the camera, so to say, so that you see everything, right? Even though you can you see all the commits on GitHub. Still, I believe this is a better viewing experience. All right, so we're going to have an element, and we're going to have a set which is going to be still empty, right after we remove an element, right? So we have an empty set, set dot empty, and we're going to do remove, and we're going to remove an element, and it's going to be still empty. At least it should, right? So still empty. If we ask it if it contains this element, it should be false. There we go. Okay, so this is surprising, and actually I'm sort of glad that this happened. This showed that we actually had a bug that I had in the very first video. Even though I was prepared, even though I was basically copy pasting stuff from my script, I still somehow managed to have this bug. And even though we had tests, we didn't catch them. We didn't catch this bug. So this is a good moment for you to realize that tests don't prove correct behavior, right? So you have to be very careful. So we are in aesthetically typed language, right? So we already have a good safety net. On top of that, we also have tests, but even then, programming is really hard, right? So what happened over here is that the implementation of remove is basically wrong, right? So I obviously know the correct implementation, but what I want to show you is the value of tests. So what you can do is you can play around with this code as long as it compiles, right? And then tests will tell you if what you're doing is correct. For example, if we do an end here, right? You can just play around and can basically guess. You can basically guess the solution because you have the system that will tell you, once you guessed correctly, you will know. So this is obviously still wrong. Let's do that. Oh, that seems to be fine. Let's do this. That's also fine. This is crazy. This shows you that maybe there is one of the tests missing, right? So if it can't be, both of them can't be the correct implementation in this case, right? It should matter if you're putting input in there or if you're putting the element in there. In fact, in this case, they actually are both correct, because look at this. It says, okay, so either they are different from each other, input and element, or if this is not the case, then they're the same, right? And if they are the same, then it shouldn't matter which one you're passing in over here, right? So this is kind of funny. So in our case, like usually, this would be the case for, for a missing test, right? But in this case, it is actually, the same thing. You could put an element here. You can put an input here. Over here, however, it's not the same. It's not the same, I believe. Let's try. Why not? You never know. See, 8 tests failed, right? So over here, you have to use the element, and over here, you probably, because it's diametrically opposed, it's better to use the input here, right? So it sort of feels like you keep passing it over. Right. In any case, this video is not supposed to be about this, but it's kind of cool. You know, we added a test, you know, and we discovered a bug. Really awesome. All right. So let's go down again. At the very bottom, we have our test that is pending. This is this yellow test over here, and this one that that throws the exception. All right. So because the tests are so valuable, we have to find a way how to you know, how to change our entire code base, basically how to change our entire sets without losing the test at the same time, right? So we want to be able to make incremental changes, even though we know that we want to replace the entire code base. So what I will do is I will just copy the entire set, right? And I will create a new file in the same folder, and I'm going to call it old set. Paste that in, and everywhere I say set, hold up. Yeah, alphabetically, not alphabetically, the case sensitive and whole word search. So I'm going to mark everywhere where it says set. I'm going to say old set. Okay. So now we have the, you know, the sets that will become the new set, and we have the old one, right? So what I will do in my test is I will try to use some Sublime magic to do the same thing. So every time, I can't just go and replace set, because then it will change also the titles, the names for my tests, right? So what I'm going to do is I'm going to try to replace set dot. So set dot is going to become old set dot, and let's see if that works. Probably it's not going to work. Probably there will be a few places where it ruined a few things. All right, so let's like usually I would look at the first one, but I'm too lazy to scroll up. So let's look at this one, 186 not found value non-empty old set. All right, so I guess that it also did something like this. So not empty old set should actually remain non-empty set, and probably the same thing with empty old set. Mark all of them empty set. At least there is a reason to my madness. All right, so all right, we're still good. Okay, so all our tests are now testing the old set and not the new set. By the way, real quick, I sort of forgot to mention this. This is I believe that this is one of the crucial points in the project's history, when you realize that the current design, like the entire current design, basically is not good enough. And in this situation, what you need is courage. You need courage to rewrite your code base, and things like, you know, aesthetically typed system, a very a safely typed system. In a language like Scala, which has a very powerful powerful type system, and also tests on top of that, right? It gives you like two safety nets, right? So those things help a lot to give you the necessary courage to start doing something. Because if you don't, what you end up is with the so-called big ball of mud, where you have basically duct tape over duct tape over duct tape everywhere. The whole design becomes horrible, and basically your job becomes very, very painful. So I just thought that I'll make a small pause and and record this message for it to be out there, right? All right, so what we're gonna do is we're gonna try to gradually we're gonna try to stick to our tests, and basically we can do whatever we want now with sets, because the old sets are still there to help with the other tests. Okay, so the idea, the big idea is to have a link between the elements, right? In such a way that we can, if we have like one part of the set, that we have some way to jump to the next one, right? So what we will need is something like this. Final case class, I'm going to call it link for now, but I'm going to rename it in just a few seconds, right? So this link will represent a non-empty set, essentially, right? So we have an empty set which doesn't have an element, and as soon as it has one element, right? So let's do element, which is a string, right? We're dealing for now with sets of strings, right? So as soon as we have one element, there should be also a connection to the other elements, and other elements is a set. It can be an empty set, right? So if this was a singleton, right? If this was a set with only one element, then other elements would be an empty set, right? But it doesn't have to be. It can be other links, right? Because link will extend set, right? And therefore, I'm just going to call it not a link. I'm going to call it non-empty. Also, by the way, there is a convention in functional programming to call something like this cons, as in construct, because this is how you construct lists or sets in this case. but I'm going to call it non-empty. And now this way we have a non-empty set, and we have an empty set, basically, right? Let's see if that compiles at least. All right, now it says class name needs to be abstract since method apply in trait function 1 of type blah, blah, blah is not defined, right? So as of right now, if we're implementing the sets, we have to have the implementation of apply. Now the empty set obviously provides the implementation for this function, but the non-empty set doesn't. So let's add one. So we're gonna do a final override def apply, right? Gets an input of string, turns a boolean equals. All right, so non-empty set. Okay, does it contain the element? Well, in this case, it's kind of simple. So it's either the input is the element, or we're going to ask other elements, right? So other elements, because other elements, remember, it is also, I'm sorry, I wanted to scroll horizontally. I'm not used to word wrapping. So the other elements are also a set, right? So we can just go to other elements and just ask them, hey, is that thing inside? Right, so our test is still green, but our tests are not even testing that. Okay, our tests, are testing the old set. Okay, but at least now it compiles. I believe our very first test is actually not testing like adding or removal. It just does something like this. Okay, let's see if that actually works with the new sets. It should. All right, so this one works. Okay, so the next one is adding. So I want to change it to set, and right now it's going to be green. So I want to rewrite it, and I want to keep it green. For the empty set, which is this test that we're having, add on an empty set, it should add the element, right? So as of right now, what we're going to do is we're going to not make this add function final. We're going to make it abstract over here, right? We're just going to remove the implementation. I'm going to duplicate that. I'm going to go down over here to the empty set, right, which is going to be another object, by the way. So what we're going to have is we're going to have another object over here. I'm going to have a by the way, this case class is going to remain private because we're never going to show it on the outside. So what we're going to have over here now is also going to be a private object, and it's going to be called empty, and it extends set, right? And as before, it's going to have apply, where the input comes in, which is a string, boolean comes out, right? And it's going to be false. It's basically this one, right? It's going to be false. So all we're going to do now is we're going to do, okay, val empty set equals, and we're just going to return this object, this one, right, like this, right? So we could have had this in one line, right? We could just have called it, with a lowercase e, right? And it would be the same. But I prefer to have it like this, because the classes, they will be called capital. And also we're going to have a better type inference much later, right, in the later videos, because over here we have a set which will always be the inferred type, but over this one the inferred type would actually be empty.type, right? So this would be the empty, the type that will be inferred, right? So for now we're just going to leave it like this, right? Okay, so now we're going to have this add function, which is going to be part of the empty set, right? And adding for an empty set should be just the production of the non-empty set, right? So as soon as you add something to a non-empty set, it doesn't matter what it is, it becomes a non-empty set, right? Non-empty with the input, and the other elements is going to be empty, right? Like this. So now we have add for the empty list, and now let's have an add for the non-empty list. Let's go over here, right? So for now, we're going to do this object-oriented approach, right? So we're going to have, an implementation of add for the empty one and an implementation of add for the non-empty one. And we're going to do this for every function, right? So we're going to have remove in both of them. We're going to have intersect on both of them. It's just gonna help a little bit. I think it's easier to understand it like this. But in fact, later we're gonna merge everything back into one. Okay. All right, I'm talking too much today somehow. All right, so what does it mean to add an element to a non-empty set? In the beginning, what we're going to do is we're going to ignore the duplicates and see how far we get there. Okay, how far we get with this, because I believe in my preparation at least, I ignored the duplicates, but all the tests were still green, which showed me that there was one test missing again. So let's ignore the duplicates for now. We're just going to create a non-empty element the same way with the input, and over here we're going to do other elements, right? And we're just going to call add on them. right? So everything is going to be like very, very recursive over here. What's happening? 39. Oh yeah, did I forget to extend set? No, this one extend set, this one extend set. Set 39. Where is it? 39. Empty. It's a set. Oh yeah, that should be empty. There we go. All right. 15. 12, 9. Oh, okay. All of them are dying basically. All right. Well, what we can do is we can comment all of them out, right? We don't need, we don't need all of them because our tests, they're still testing the old implementation, right? Except for this one and except for this one. Okay, so let's keep going like this. Let's go with a set. All right, so this one failed. Why did it fail? Add an nonempty set should yield a new set with 2 elements. False was not equal to true. All right. Let's look at our add. All right, there we go. It just says nonempty input other elements add. Oh yeah, it says input, but we should have added the element, right? So we have other elements add element, right? So basically we're recreating an entire set, right? We're creating a non-empty set which contains this newly added element, right? In this case, for example, this one, right? And it makes sure that the other elements still contain the current one, the one that is, that is being linked. So we're just gonna keep going like this. Okay, so we have remove. Okay, so let's just, duplicate that and have remove over here. Let's remove. Okay, so at first we're gonna duplicate this, go down, and we're going to do this for all of them, right? So our first tests are for the empty sets, right? So for this one we can just throw an exception for now, but for this one we will actually need to implement it, right? So let's find our test that removes an element, this one. By the way, this is the one that we added today actually, right? So let's switch it to sets, and as of right now it should explode, right? Because what does it do? Value remove is not a member of collection set, line 36. What? Remove. All right, hold on. Let's say, by the way, I want to do final override over here and final override over here. That's not going to solve our problem, but still. There we go. What? How did that solve our issue? Okay, so the test obviously still fails because we don't have an implementation. So what does it mean to remove an element from an empty set? Well, it basically means that it's just going to return itself, right? So it's just going to return this, right? It's gonna remain empty. Okay, and now the test is green. Let's go to the next one, this one. Okay, so over here we're actually removing an element from a non-empty set, and as of right now it throws an exception. Okay, so what does it mean to remove an element from a non-empty set? Well, if it's the current element, right? If this equals element, because remember we always have access to this current element, right? So if it is this element, then just return other elements, right? By the way, this will only work if add is doing its job, right? So if add actually removes the duplicates, right? Then remove has to remove only one element, right? Because as of right now, it can happen that we have the same string multiple times, and with this current implementation, we will remove it only once, but we actually need to remove all of them because our add is sort of broken, right? So actually let's leave it to do over here, to do fix. Okay. In this case, it should be enough. Okay, so if this is the same as the element, then other elements. Otherwise, let's just throw an exception for now, because I believe in this case, our test. No. Oh, by the way, this shouldn't be this. It should be input. Input equals element, then other elements. Otherwise, throw an exception, right? So we can throw an exception because we didn't comment in the code that tested this branch, right? So it's this one set over here, right? So now this exception should be thrown and the test should be read. Okay, so how do we remove an element in this case? Well, we're just going to basically removing is also reconstructing another set, right? So we're just creating another non-empty set, right? So we're creating a non-empty set with an input. We know that it's non-empty, right? So think about it. If this was the set was the very last element, right? Then this would happen. Other elements and other elements would be empty, right? So this is how we know that in this case we always can produce the non-empty set, right? So over here we have the input, and we're just gonna go to the other elements and remove the input again, right? So I'm gonna also leave a comment over here. I'm gonna say to do fix, okay? Oh yeah, no, I actually made a mistake. I don't know what's happening. I should record videos in the morning. I'm sort of not awake yet. So over here we are producing a non-empty set without the input, right? So we're producing a non-empty set. We're keeping the current element, right? And we go to the other elements and ask them to remove the input. See, this is so great to have tests. Like I can even program this like basically when I'm asleep, right? All right, let's go with the next one. Remove removes only the element in question. So we have a set over here. That should be fine. All right, so now all the tests are passing, and this is the moment where I realized when I was preparing for this video that one of the tests is actually missing. So let's make sure that add also removes the duplicates. It's not so easy to test though, right? You have to think about it, because like usually the way you would do it is you add the same element twice, and then you have a way to calculate the size of the set, and you just make sure that it's still 1, right? But as of right now, we don't know how to implement the size yet, right? I mean, by now we do know, but we didn't get there yet. So I found a tricky way to do this was test through the add and remove, right? So the fancy combination of add and remove. Okay, so I'm gonna call this test add remove combo should ensure that all elements are distinct, right? So what we're going to do is we're going to create an element as always, which is going to be a random string, right? And then we're going to construct a set by adding the element twice, right? Adding the element twice, and then we're going to remove it, right? And we're going to ask the element, ask the set if it's now in there or not, right? And it should be false. Right? So this way, we're forcing us to actually change this code, which is sort of like one of the core ideas behind test-driven development, that you're sort of not allowed to write any production code for which you don't have a test, right? A failing test, right? So now we do have a failing test, right? It makes sense, right? We're adding the same element twice, right? And then we're removing it, and then we're asking, hey, is it there? And it's going to say yes, and it's happening because remove did not remove all the same elements, right? Because it assumed that add is doing its job properly. So, for example, the wrong way to fix this task would be also to say, okay, let's remove it again, remove the current one and also remove it from the other elements, right? But this is not the solution. Like, our remove is correct. So our remove is doing its job properly. The problem is our add, right? So in our add, we have to say if input equals element, right? In this case, we're just gonna return this. Otherwise, we're gonna return a non-empty set. And by the way, I haven't actually explained to you in the previous video how scalar reform works, right? So as you can see, this code is poorly formatted now, right? And by the way, we don't need this comment. Right? As soon as I save the file, SBT will actually see it said formatting, and then because it actually had to format something, it actually said reformatted one of them, right? And then it compiled, and because of this, occasionally you will actually see the continuous compilation or continuous running of tests. You will see twice, right? Because what happens is that you change some code, you save the file, then it formats them, right? It compiles them, right? I think the compiling is happening first, and then the formatting is happening, and then SBT thinks that you change the files again, right? So it reruns the whole thing again, right? Okay, so now our add is perfectly fine. And by the way, look at scalar reform, right? So if we just do this, like if we do like really crazy things over here, it's just gonna fix everything. Like I'm not touching anything, and it just fixed our entire code. It didn't fix this one, for example, but at least we got something. Okay, all right, let's keep going with our tests. Okay, so we have union, and let's just go and say set, Okay, over here, and now it's going to say, okay, union is not defined. So let's actually define union. Let's do this like that, and by now we can remove that. Okay, so duplicating the line, bringing it down to the non-empty one, right? And it's going to become a final override. And as always, the first step is to throw the exception. Go down over here to the empty one, do the same thing. All right, there we go. Okay, so what does it mean to compute a union from an empty set? Well, if it's an empty set, then a union with any set will be just to return this any other set, right? So this is going to be the union for the empty set, and this is why the test is already passing. What about the others? All right, so this is the next one. Let's just do set over here, right? And let's see that it fails. Okay, it fails. Okay, so a union for a non-empty set, like this is an interesting one, right? So basically what we need to do is first, right? Let me make sure that everything is looks well. So first we need to create a new set which basically contains every element of that test, right? Which contains the element from this one, right? So we're creating a new set which takes the other set and adds the current element to it. Like this is the first step, and the second step is to ask the other elements to do the same, right? So we're going to go to other elements, right? And we're going to ask them to calculate the union of the new set, right? Let's see. And it works. And by now we can just inline that, right? Ta-da, 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 like this. And if this is happening, too fast, then remember that this code is on GitHub. Just clone it, play around with this, change a few things, see which tests are breaking. All right. Okay, so let's continue. Yeah, we have more tests for this, right? So let's just do that, but they should still be green because this is already a correct implementation. All right, let's do the intersection now. Let's go alt set.empty. There we go. Okay, intersection is not a member, right? So let's do this. Notice that all the functions that we're implementing, oops, forgot the def, the structure will be really the same. And in fact, in the future videos, we will notice that, and we will create an abstraction over that, which is going to be really beautiful. Okay, so this is going to be final override, and it's going to throw an exception as always. It's not implemented yet. Same thing for this one. There we go. All right. Okay, so an intersection on an empty set. Well, an intersection on an empty set is always an empty set, right? So we're currently right now in the empty set, so we can just return this, right? So if you take an empty set, you intersect it with whatever you want, it's still going to remain empty, right? There are no elements, right? So let's do this, and the test should be green. All right, cool. All right, let's just continue, and we have this one. Nope, that's too much, just this one. All right, so an intersection on a non-empty set is actually going to be not that much trivial, right? So let's have a scope here. Every time you're like sort of predicting that something is not going to be trivial, just have a scope, so that you kind of feel like you have a space to work in, okay? So let's see. So if the element that is present in this set, if it is also present in that set, right, then the set that we're constructing has to contain this element, right? So what we're going to have here is we're going to say, okay, let's go to other elements and calculate the intersection of them with that, right? So we're basically recursing further down, right? So we're doing the same thing, right? And whatever comes back, we just need to make sure that the current element is also added, right? Because it is contained in both sets, right? So element means it is contained in this set, and if this returns true, that it means that it is also contained in that set, right? So whatever set we're constructing, which is going to be this one, the intersection of other elements and that, right? And we need to make sure that the element is added, right? And otherwise we're going to do the same thing, but we're not going to add the element, right? And that's going to be the entire intersection, actually, right? And we're just going to refactor this a little bit. We're just going to cut this out, and we're going to say intersection of others, right? Because we have to do this anyway, right? It's going to be this, right? And now we can say intersection of others add, otherwise it's just intersection of others, right? Right, so if this element is present in both sets, then we calculate the intersection of the others and add it. Otherwise, we just calculate the intersection of the others. And I believe this should fix all the intersection tests. This one. Yeah, there we go. All right, let's continue with the difference. Most of these transformations are very mechanical, as you can see. Right, so we have the difference. Let's just do that. Copy that. Actually, forgot to remove them. Okay, duplicate that, go down over here, final override. As always, it throws an exception, right? Let's duplicate that, go down. Very, very mechanical. All right, so at least now it compiles, but now it should throw an exception, so it should fail. Okay, so what does it mean to calculate the difference on an empty set? Well, it means that you're asking the other set whether it has something that you don't have, but you don't have anything, right? So the result of that is going to be an empty set, and in this case, we are already inside of the empty set, right? So it's going to be this, right? There we go, it's green. And what about the next one? That should still throw the exception, right? Let's go down, let's go up here to the difference. And the difference is going to be almost exactly the same to, you know, with the intersection, right? So what I'm gonna do is I'm gonna copy everything over here, right? And I can do silly things like this because we have tests, right? So everywhere it says intersection, I'm gonna say difference, right? But something has to be flipped. Remember, the intersection was that it, you know, that the element is contained in both sets, right? Which means this contains and that contains, whereas the difference was this contains and that does not contain. So basically, I just need to flip this if expression, right? So only in this case, I'm going to add it. In this case, I'm not going to add it, and that's it. All right, let's see the others. Set. And by the way, remember that the difference is not commutative, and we're testing it actually both ways, which is kind of cool. All right, let's see what's left. Oh, we're done. So we finally arrived at the isSubsetOf, and this is the one that we wanted to test. Okay, so let's first of all not make it pending. And by the way, at this stage, hold on, let's leave it pending. At this stage, we don't actually need all the alt set anymore. Let me reveal it in the sidebar, and let me just remove it, delete file, and everything should still be green. Okay, except for, you know, the very, very last one, right? This one. Right, so at least now it should compile and everything should be green and or yellow. And now it says isSubsetOf is not there. Okay, well, let's add it. So def isSubsetOf like this, right? Let's remove that. Okay, let's do the same. Okay, this one returns a boolean. This was the issue because it was returning something else other than a set, right? So let's go down. Okay, difference was the last one. Okay, over here, right? Over here, we're gonna add it. isSubsetOf boolean, and we could also just say false, but let's throw an exception as before. Oh, forgot to do, hold up, let's remove this. Forgot to do final override. Okay, and we're gonna have it over here, right? So at least now it should compile, right? And the test is still yellow, and by now we can remove the pending thing and see that it's actually red, and we can start implementing isSubsetOf. Right. Okay. So what does it mean for an empty set? You know, if to call isSubsetOf? Well, an empty set is a subset of every set, right? So in this case, it's just going to be true. All right. And the test is green. So let's have a test, and we're going to say isSubsetOf on itself should yield true. Okay. So let's create a set.empty. Add random string, because remember, this is how sets are defined, right? So let's go down and we can say set isSubsetOf set should be true, and let's see. In this case, it's going to call, you know, the one that that throws the exception, right? this one. By the way, Sublime doesn't always show that I saved the file. Have you seen this circle? Like, it was still there. I'm not sure why this is happening. Actually, it's kind of weird. All right, so is subset of on a non-empty set? Well, we're just going to ask the other set if it contains the element, right? And if other elements is subset of that. And that's it, right? So now, because we have the link, because we can touch all of them, right? We can touch the current element. We can do this sort of like recursive jumping around. We can do this set walking, right? It's called traversing. In programming, every time you traverse a data structure, you walk through a data structure, it's called traversing, right? So now we have a way to traverse the set. Okay, let's add another one. Let's have this one test. Whoops. isSubset of on a non-empty set should yield false. Right. So in this one, we're going to construct a situation where there's always going to be false. So we're going to have A equals random string, B equals random string, C equals random string. Okay. Let me scroll down a little bit. So we're going to have a left, which is a set.empty, add A, add B. Okay, we're going to have right, where we're going to take the left and we're going to add C. Okay, so for the left one, left should be subset of right, obviously, right? Because right has just one more element, right? So that's going to be true, should be true. But the other way around, it can't be true. Whoop, that sets it. Okay, isSubset of, come on, left, that one should be false. And it works, right? It should work. Come on, yeah, there we go, it works. Okay, so as soon as we have subset, we actually have superset kind of for free. And let's implement a few tests for supersets. Actually, I don't want to waste your time. So basically, the supersets for tests are going to be the same as a subset of, but they're just going to be reversed, right? So I'm going to copy them from my script, and again, if it goes too fast, you can just look up at the commit, right? So, but look at this one. This is basically the same test as the this one. It's just that it's flipped, right? So we're saying, okay, set empty is superset of set empty. Okay, this one still should be true, right? But if we add an element and then we're asking, like, is that a superset of an empty set, it is going to be true, right? So for this one, it was also true, right? So the empty ones, they're not even flipped, right? But the other ones, they should be, right? So okay, superset is actually also true. Because every element is every set is a superset of itself, because every element, every set is a subset of itself, right? And this one is flipped, right? So it has to be false and true, and the other one has to be true and false, right? And because it's such a, it is always basically just a negation. What we can do is we can just go over here into the tray, which can be sealed, by the way. I'm going to make it sealed in just a second, right? So what we can do is, let's have an empty line over here. And what we can do is we can have a final def is superset, I think I'll go like this, right? That set boolean is going to be not a subset of that, right? What the hell was that thinking? No. The reverse is actually, so before we were always doing basically this is subset of that. So the reverse is that is subset of this, right? So now you sort of get the superset for free. And because we have a subset, and actually superset, but we can ignore a superset, because we have this subset, we have the equality for free. Remember how equality is defined on sets is basically if set A is subset of set B and set B is subset of set A, then they're equal, right? This is how equality is defined on sets. So we're going to implement the tests for equality a bit later, in some later video. For now, we're just gonna plain, we're gonna enjoy the fact that we're getting the equality for free, right? So we can do final override. Remember that equals is defined on any or on any val, right? final override def equals. Please always add the override keyword to equals, because then it will make sure, the compiler will make sure that your signature is correct, and the signature is going to be that over here we have an any or an any ref. It doesn't. I believe both will work. Actually, we can try that. Let's do boolean equals whatever. Let's just do false. Doesn't really matter. Let's just try any ref. I believe any ref should still be fine. Oh no, it's not fine. Okay, so any ref should be any, right? Because see, it's things that you're overloading now, and so on. Okay, so let's do any. Okay, and now all we need to do is we need to pattern match on other, right? And if it's a set, remember, because over here we don't have the type, and if that's a set, then we're just gonna say, okay, if this is subset of that, and that is subset of this, well then they're equal, right? And otherwise we're just gonna say false, right? And as I said, we're gonna add, like, you know, full-blown test suite for equality later, but we already can test equality sort of for free, right? Because we already have a bunch of tests that could use equality, right? For example, even the very first one, if we go up, remember this was like the sort of the silly one that doesn't actually, you know, properly test anything, right? Instead of this, oh, actually no, I'm sorry, this one we can't do yet. We need the size for that one, right? Because all we can do now is we can say, okay, set.empty should be set.empty. Sure, but this one is even more silly than this one, right? Because this one would actually work even without this, I believe. Let's see. Because it's reference equality, right? So it doesn't actually test shit. Okay, so let's remove this one now. But a bit later in actually in this video, we're going to implement the size just for this one. Okay, but what we can do is we can go, for example, to the union, right? This is the first test for the union, right? And it's doing this silly thing again, where it generates a random string and then basically says, okay, whatever you're doing here, this should not be contained. And as I already said, this is not, you know, not really a good test. So what we can do is we can do this. We can do empty, right? We can do we can do union, right? Equals empty union empty, right? And now what we can do is we can say, okay, empty is subset of union. Should be true. And union, whoops, union is subset of empty also should be true, right? And what we can also do is we can do the equality thing, right? We can do set.empty dot union set.empty. Well, it should be set.empty, right? Because should be is going for equality, right? It just compares for equality, right? So in fact, damn it, I believe this one would even work without it. Yeah, this one even works without it, but the next one won't. All right, so let's remove these and just have that. So over time, our tests are gonna become shorter, right? So let's go to this one, for example, right? This one is a big one, right? It tests the union, right? And what we could do is we could go down here. Right, so remember over here we have the left one and we have the right one. We calculate the left union and the right union. It's commutative, but we're still testing it, right? And then we have to have like 8 lines just to make sure that, you know, the elements are actually contained in them. But now that we have equality will do that for us, right? So what we can do is we can just say left union right should be, and now we just construct a set that it should be, right? So all the elements should be inside, right? So this is a set which contains A and B and C and D, right? And the other one should be the same. I'm just going to duplicate this line and I'm just going to say right union left should be that, okay? And now if I comment out equality, now it will actually fail, right? So this is basically the first test that actually, you know, tests equality. And now because we have equality, we don't have to do all of this, you know, ourselves, right? So we can just remove all of this and now our test becomes shorter, right? And we can do the same thing for the intersection, right? So if we go down to intersection over here, right? So what we can do there is a very similar trick. So we can do left intersection right should be set.empty add b add c, and if you don't remember why, it's because over here b and c, these are the ones that return true, right? And if I duplicate that and I say right over here, I say left over here, it still should be exactly the same, right? So now I'm running the test, and if I could spell properly, then I will be fine, like this. Right, there we go. And now we actually don't need this whole thing over here, right? And we can do the same thing for the difference. So if we go down to the difference, I have the left and right difference. So we're gonna do left dot difference right. Should be, by the way, a bit later we will also have a more convenient way to construct sets, and our tests are gonna get smaller again. Okay, so for which one is true is only for A. So let's do this, duplicate the line. This is going to be right, this is going to be left, and for this one it's only D, so this one, right? So now it's green, and let's remove that one. Okay, all right, so this video is getting a bit longer, but I actually wanted to include a few more things in this one, right? So every time we implement equality, like even though we didn't implement the test yet, we really should include equals. So what I'm going to do is I'm going to implement it right now. So we're going to implement the hash code and the size today. All right, so hash code on an empty set. What is that? Whoa! I'm using a wireless keyboard, and maybe its battery is dying. Okay, so a hash code on an empty set should not be random. Like, this is the very important test, because by default the hash code is basically a reference, the address of the reference, right? So so what we do here is we're going to do set.empty hash code should be set.empty hash code. Actually, in this one, I believe that this one actually might be green. Yeah, this one is green. But if you have a set.empty add an element, it's going to be here, right? It should be the same thing again, set.empty add element. So this test should be still green because we're comparing them for equality, but as soon as we're comparing hash code over here and hash code over here, come on, code over here. Now this one should fail. The cool thing is that it doesn't fail because we're using case classes, right? So we're getting hash code for free. We actually were getting equality for free as well, I believe, but this was not the proper equality, because we had a task that failed when we removed it, right? So let's demonstrate that. So if we do that, then there was one test that was failing. Actually, let's see why it fails. Union to nonempty set should yield error. Oh yeah, because in this case it's actually it doesn't know the types, because we're comparing, you know, a regular set to an empty set, and then the equality on this trait is being called and it's not implemented, right? So the default equality for this one is actually to compare you know, non-empty sets to non-empty sets. Otherwise it's just going to say false, and for this one it's just reference equality, right? So our equals method was actually worth it, but our hash code maybe doesn't, right? Because the hash code is fine for this one and for that one, and yeah, it should be fine. But still, let's keep adding the test. So what I want to have is that a hash code on an empty set should not be 0. It's never a good thing that it's 0. Zeros are not good in this case. So let's do a set.empty hash code. By the way, let's have an empty line over here. Okay, so, and also over here, set.empty hash code should not be 0. Let's see, the default implementation for the hash code should not should not yield a 0. All right, yeah, it's fine as well. Okay, so let's go further. Actually, no, I have another test prepared because, you know, in my preparation I actually implemented my own hash code method. So I guess it should be fine. By but still, I want to have like a bit more control of the hash code. So let's just go and implement this one as well. So hash code on a non-empty set should be the sum of all the hash codes and the hash code of the empty set, right? Because it's very, very, very important that that the same sets hash to the same value, and I just want to have more control over this. Therefore, I'm just going to have a test that has the first element and has the second element. Whoops, not TS, RS tab. All right, there we go. So what we expect is an empty hash code, right? Plus first hash code plus second hash code, right? So we're gonna have an empty set. We're gonna add the first. We're gonna add and the second hash code should be expected. There we go. And this one actually fails because the default implementation for hash code in case classes is different. And I'm not sure why I have it in my script like this. We actually don't need that. Let's do that, and let's do that. There we go. And say final override def hash code. What's happening? Hash code, which is an integer, equals element dot hash code plus other elements dot hash code. I believe this should do the trick. All right, all the tests are green. In fact, in my preparation, I actually went over here and actually said, okay, you know, the hash code for the empty set should be 41, but in this case, it doesn't really. It's not really necessary. In fact, why don't we define that at the top actually? Over here. Why don't we do that? It should be fine as well, right? Oh, because it doesn't have the element, it doesn't have the other elements. Okay, there we go. All right. I should not experiment while I record. All right. So all that is left to do is to have the size, and I really don't want to waste your time with tests because I have a lot of tests. So I'm just gonna add all the tests for the size. Right, and they're very, you know, they're very clear, right? So an empty size should be 0. You know, if you add one element, then it should be 1, and if you add two elements, then it should be 2, and then if you add the same element twice, then the size should still be 1, right? So let's just add size to the sets at the very top. Okay, so we're just gonna have let's add down over here. Let's do def size, which is an integer, right? Go down, implement it. Okay. We can actually, you know, it's so simple to implement size so that we can actually do it right away. So size of an empty set is obviously 0, right? And the size of a non-empty set, right? It is just going to be 1 because non-empty set has at least one element, which is this element, plus other elements that size, right? Just like that. And now all the size tests are actually passing, and now we can actually go to the very, very, very first task, and we can say, and this is how we should test the empty sets, right? So the empty sets dot size should be 0, which is actually, you know, the test that we already have, right? So if I do this, I press Ctrl D, my Sublime should jump over there to line 257. Okay. So what is left is, you know, because we have size, let's also add a few cool methods. The first one is going to be empty, right? So I want to be able to ask a set if it's empty or not. So I'm just going to add the test for the empty one, right? So an empty set should obviously be empty, and because there will be an isEmpty method, there will be also a method called nonempty, right? So which we sort of get for free, right? And then we as soon as we add an element, then it's obviously should be reversed. Okay, so let's go and add that. So let's go to def isEmpty, which is Boolean. And we're going to get one for free, nonempty Boolean equals, well, not is empty, right? I love free methods. Okay, so if we do this, we go down all the way, This one is going to be true because this one is empty, right? And this one, override of is empty is going to be false, right? There are many ways to implement this. Actually, what's happening? Method nonempty overrides nothing. What? Where did I do that? This one, it actually doesn't override anything. It's just a final method. All right. In fact, this one, I believe for this one we will actually make an exception, and we're gonna say that. Should I do this exception? Because this is an ADT, and by the way, this is a reason why we should seal this trait. So if you seal this trait, then this becomes an ADT, and then we can just have a final def is empty over here, and we can just check for the type, right? So we can just say. In fact, we don't even need to check for the type. We can just do the reference equality to the empty set, right? Like this. Actually, let's do that. Why not? Let's do that. This equals empty, not found value empty. All right, because we need to say set.empty, right? And now we're trying to override stuff, and there is no reason to do that. Let's comment this out. Comment that out. Right, and it still should be the same. Yeah, you know what? I'm just gonna do it like this. But this one I'm gonna make an exception. Usually exceptions are not that good, but in this one I'm gonna do. We're gonna have it because it's just so. Performance-wise, it's the same thing, and code-wise, it's a bit less of code. In fact, in one of the future videos, we're gonna do the opposite. So right now we're splitting the implementation between the empty and the non-empty set, and in one of the future videos, we're actually gonna collapse them into one. Okay, another one is a method that it is actually not present in the real collections library, and also I haven't met a collections library that has it, but it is actually kind of cool to have a method called isSingleton, which is going to tell you if the set contains only one element, because we obviously could implement it, like every client could implement it by just saying, okay, if the size is equal to 1, but it's way less efficient, right? Because if it's not equal to 1, right, it could be a set that contains 1 million elements, and all you care about is to check if it's empty, and for that you would need to go through all the elements and calculate their size, right? Because over here we have access to these private instances, we can implement this way more efficiently. So let's just do that. So we're going to have tests for isSingleton, right? And the empty test is not a singleton, right? And this one is also not a singleton because it has 2 elements, right? And as soon as, and this one, which contains only 1 element, this one should be true, right? So let's implement that. Let's go over here and let's have def isSingleton boolean, okay? Duplicate this line, go down. Go to this one, final override def isSingleton. This one is obviously going to be false, right? And the other one is going to be right. So what does it mean for a non-empty set to be a singleton? Well, it just means that the other elements are empty, like that. Then it's a singleton, and that's it. That's the entire implementation. And this is, by the way, also one of the reasons why sometimes people are lazy to write tests, because the implementation is so simple. It's just so obvious. But the tests look already we have only 100 lines, 110 lines of stats, and we have 300 lines for tests. And this is one of the reasons why people are sometimes reluctant to write tests. Okay, the last one for today is going to be also a not very common function to have in collections, and it's going to be a function called sample, right? Sample should yield a random element from the set, right? I just kind of thought, I just randomly thought that, hey, we should have this function. And by the way, in the future, like once we, once the design of the collections library is going to be like a bit more finalized, feel free, just as an exercise or whatever, to submit pull requests, because there can be like hundreds and millions of beautiful functions that can be defined on collections, right, on sets and whatever. And obviously, I'm not going to add all of them, right? But feel free as an exercise, if you want to practice like how to write tests, if you want to, play with collections, feel free to submit a pull request. All right, so this is going to be the last test, which is why I'm going to type it out. So we should be able to say sample even on an empty set, and the signature of the sample is going to work in such a way that it's going to return an empty option, right? If it's not possible to construct this random sample, right? So we're gonna implement all the cases in this one test. Right, so we're gonna have an A, which is gonna be set empty at A, and we ask for the sample, and it should be sum of A, right? And in this case, the last one, it's gonna be the last case that we're gonna write. It's gonna be a random string over here, right? We're gonna set that empty dot add A, add B dot sample. Should be, and this is one of the cool things in Scala test. What you can do is, instead of saying should be, you can say should contain one of AB, right? Because remember, sets don't have an order, right? And because they don't have an order, I have no idea which one will come back. Now, because I know the implementation, right, then I actually know that this will always be A. But it's a really, really bad idea to have your test know about the implementation, right? So we're not going to assume anything, right? Okay, so this is the last one, and let's go up and define it. Let's define it over here. Sample, which is an option of, in this case, string, right? And this is, by the way, already generics. Remember that I'm using the collections as a vehicle to arrive at generics. But we haven't arrived at generics yet. But I thought that we already stumbled on option a long time ago, and I thought why not just include it? Okay. So let's go down. As always, we're going down over here. We're going to have a final override def sample, and in the empty case, there's no sample, right? And in the non-empty case, which is this one, it is going to create some of the element, and that's it. That's all that it's going to do. So it should be over there. Should be none. Gonna get scared there for a second. All right, so we have 36 tests, and this is, I believe, all that I wanted to do for today. And let me just look through this real quick, because as always, I want to commit this was the message of the video. So give me a second to review that stuff. All right, so I just reviewed it, and it turns out that all I had to do was, I didn't have to do it, but all I did was I created an empty line between isEmpty and nonempty, so we're actually fine for today. All right, so let's kill SPT. Whoops, that's not what I wanted. I wanted to kill SPT. Come on, Control D. There we go. All right, so we have changes, git status. We did, we modified set and we modified set suite. Okay, so let's add everything. Even though it's added, it's nice, it's not gonna hurt. All right, so commit everything, and it's gonna say video 2, and this is going to be I'm gonna call it non-empty, right? Yeah, that should be enough. Commit not empty, right? Git push my key, because I'm using SSH. Whoops. Come on. There we go. So now if we go to GitHub, let me maximize that. And then if I refresh, then we should have 4 commits, right? So now you can see, okay, we had the video 1 and we have the video 2, and you can go here and you can see exactly what changed, right? So see, this was our old implementation, was completely deleted, completely removed, and now we have this one, this beautiful one. Most things are added, some tests have changed. Yeah, so I hope you liked this video. Like if you did, it really helps me a lot if you like this, because this increases the chance of other people to actually discover my videos, because YouTube's gonna show them more often. And yeah, subscribe if you want to improve the developer inside you, and most importantly, take care.